This video is about two things. One thing this video is all about, it's about the vector representation of Coulombs law and the electric field intensity equation. So Coulombs law is a universal law which says that F is equal to K Q1 Q2 divided by R square, and the force between two objects or 2 point charges, so this is the point charge Q1 and Q2 separated by a distance of R, is directly proportional to the charges and inversely proportional to the square of the distance. And some of the other things, which is the K is equal to 1 upon 4 pi epsilon naught. The value of the epsilon naught is equal to 8.85 into 10 raised to minus 12 farad per meter. So these are the universal law, and this is how the Coulombs law is defined in mathematically, and the unit is Newton. So this is a mathematical definition of Coulombs law. So considering the same in vector, so force is a vector quantity. So how to find the direction of the force? In vectors, so whatever I'm going to explain is not as per scale, and it's just for representation. But if you are drawing it as per scale, you will be able to find the correct answers. So I'm considering an origin or reference point, and I'm considering a charge. So I will just draw it in a fresh page, so it's better to understand. And I am considering a origin point. This is not as per scale, again not as per scale, but I am representing 2 point charges. One is Q1 and the other is Q2 by using the position vector R1 and the position vector R2. And now I have to find the force between these 2 points. So this is the distance between the 2 points, can be given by arrow which will go to here. So it will approximately something like this, and this will be my R12 vector. So this is a distance. So, and if I assuming that this is a positive and this is a positive, and the previous videos you saw that by the law of static electricity, both the charges will repel each other. So in this case it will repel each other. The direction of the force F12 will be away from the charge Q2. So F12 will be equal to K of Q1 Q2 divided by R12 whole square, and divided by the unit vector of R12, which is in the direction of which is a vector which is giving the direction from 1 to 2. So this is from the definition of Coulombs law, and we are giving the direction of the vector using the position vector. So again the question comes as how to find the value of this vector. So it is found out that this distance, if you are drawing this R1 below here, that is in a way you can say that this is your minus R1, and you are adding it in such a way that R2 plus minus R1. So this is your R2 vector, and when you are adding it in such a way R2 plus minus R1, the minus r1 vector will look something like this. This is my minus r1 vector, and if I am drawing this, joining these two lines, if I am drawing these two lines, then what I will get here is r12 vector. So the same thing I am projecting it here, and I am finding the distance here. So the r12 vector is equal to r2 plus minus r1 vector, or in simply r2 vector minus r1 vector. So it's possible to write the equation as F12 force is equal to K Q1 Q2 divided by r1 minus r2 vectors magnitude whole square, which will give me the distance, and then the unit vector r12, which is the unit vector of this. So this is how I am finding, or this is the vector representation of Coulombs law. So the next of our topic is defining the electrical field intensity. So what we have done is that we have defined, we had 2 point charges Q1, we had Q2, both of them separated by a distance r1, which is a position vector, r2 and this was a position vector, and this was a distance between them r12 vector, and we found out the force F12. So the equation was F12 is equal to K Q1 Q2 K Q1 Q2 divided by r12 whole square, and the unit vector r12. But I am assuming that now that this is a unit test charge, or this is a stationary charge, and this is a unit test charge. In any case, you can take whichever as you want in a test charge. So this is a test charge. So the electrical field, or the force due to F21 divided by Q1, the case where this is a unit charge and you are having an electrical field due to a unit charge, and you are bringing a test charge along with around to test it. So it can be found as KQ2 divided by R12 square into the R12 unit vector, and what is this is known as force per unit charge, is known as the electrical field intensity of that charge. So this is the electrical field intensity on this unit, felt on this unit charge due to the charge Q2. So this is the equation of electrical field intensity due to a point charge, and the equation of the electrical field intensity E is equal to Newton per Coulomb. So that's moving one step ahead, and how to find the electrical field intensity due to a point charge.